Okay, so I want to spend a little bit more time tonight looking at the correlation coefficient. We need to get familiar with these numbers and what exactly they mean for our data. And we've sort of talked about this a little bit before, but I thought this might give you a better idea. Um, One is a perfect positive correlation. So that means whatever x is, it directly impacts the y. One affects the other. So it should make pretty much a straight linear line. Zero, of course, is no correlation. -1 is a perfect negative correlation. So again, you should have a negative looking line. But there's been sort of some, I don't know, not quite sure about what we get, how the correlation is affected when it's not quite these numbers. This has a zero point 0.8, so I would say anywhere below 1 and zero point 0.8 would be your high positive. So again, you could draw a straight line through those and the points would be tight. So we consider anything down to a zero point 0.8 a high positive. A low positive is, again, you can definitely see it rises from left to right, but it's weak. They're spread out. They're not as tight as if I were to draw a line right through here. They're kind of spread out farther from that line, excuse me. So we said 0.5, but they're saying 0.3. So we could say put between 0.5 and 0.3, you're going to have a low positive. Anything where it's scattered, where you can't figure out how to draw a line through that, it's going to be a no correlation. And then again, we have the negative. We have negative 0.3, so that's going to be a weak negative. So again, we could draw a line through here. It's definitely going left to right, following. But again, if I were to draw this line, the points are loosely around it. Negative 0.8, again, if I drew a line, these are nice and tight. They would all be hugging this line. And these are all lined up in a perfect linear function. So the R tells you how much the X and the Y are related. So I would like for you to pause the video and get out your calculators. We're going to show you a couple things on there. We'll talk about the R again. So we're going to look at this situation. The table below shows the time spent by 9 students working on a community service project and the amount of money they raised. So we have the time spent in hours and the money raised in dollars. So again, just like when it's set up as a vertical chart, the top is going to be your X and the bottom is your right. Usually this is always X and that is always Y. Okay, so X, time spent in hours, again, time is going to be our independent variable and the money raised in dollars will be our dependent. So we want to get out our calculators and put in this data. So you might want to take a minute and pause the video and put this in your calculator. Hopefully you remember that you're going to hit hit on first, stat, enter, and enter. What's going on? Technical difficulties. Okay. And again, you can do clear the column by highlighting the L1 and go clear, enter. So go ahead, I'm going to move this down so you can see this data and put this data in your line 1 and line 2. Go ahead and hit pause. When you're done putting in your line 1, line 2, always, always, always check your data real quick. Make sure that you have all those in there correctly. Because like I said before, one off will throw the whole thing off. So you don't want it to get the problem wrong here. And you also want to make sure always that these columns line up. If one is off, then you missed a piece of data. Okay, so we're going to do our linear regression like normal. Well, actually, let's set our window and graph it first. So we're going to set our window. Our minimum is 1.5. So let's go with 0. Our maximum is 4.5. So we'll go with 5. And I would probably go by, let's try halves. Might need to go lower than that, we'll see. Alright, and again our minimum here is 50, so we might maybe put in 45. Our maximum's 100, so I might put 110. And I think we probably go down by, oops, I did that off, right? Yeah, this is supposed to be 110, oops. 110, and then the scale I think we'll do is 5. Okay, so let's graph that. This is like your little wheel thinking. Okay, so nothing came up, so I'm guessing that my stat plot's not on. So I can just go y equals, and can go up to stat plot and just hit enter, and now it's highlighted. Or we can do second stat plot and go in and turn that on. So here's my graph. It looks pretty good. I might say that's a strong positive possibly, but I think we should put our trend line in there to make sure. So I want to show you a little trick. Might want to pay attention because will save us a lot later on. So we're going to go to our edit calc and 4 and enter. Then okay, so I'm going to take that back. So clear that out, sorry. You want to go to Stat, Calc, 4. Now don't hit enter here. That's my mistake I made. I hit enter. Okay, so once we get to here, I'm going to show you a way where you can get the equation put in your y equals for you. So we go to the vars, hit vars, right arrow over to y vars, because we want this to go into our y equals, and then we hit enter, and we want it to go into y1, so we're going to hit enter again, and then hit enter one more time. Okay, so all of this comes up, our slope, our y-intercept, our r. But look what happens when you go to your y equals. It put that equation in your y1 for you. So I saw some of you guys the other day try to write all these in here. So I thought this might be a good one. So again, we went to, just to recap, we went to stat, calc 4, and then we went to vars, right over to y1, y vars, and then y1. Okay, so then if we hit graph, there is our trend line, and we can see that these are pretty tight. Okay, if we go to our R, it's a 0.9, which is strong. So what I want you to get used to doing is talking about the correlation. There is a strong correlation between the time spent, hours on this community service, and the dollar that they raised. Okay, so that is kind of the underlying sentence you want to be able to write, is there's a strong correlation between the time spent in the community service in hours and the money that they were able to raise, because it's 0.9. Okay, so that was a little trick. The last thing I want you to do is I want you to look at this. Let's see, I'm gonna have to, there we go. So here I want you to do on your own. You have A, B, C, D, E, and F, and they have R equals here. So all you have to list on your paper is A, B, C, D, E, and F. And I want you to pick which R values you think will go with which graph. Okay, so for this one you put R equals, and you'd pick one of these to go with that, and that one of those to go with that, and that's it. So hopefully we have a little better understanding of our correlation coefficients, and we'll work on this a little bit tomorrow. Good night.